Okay, let me walk you through my solution here, and this should be pretty straightforward. Again, the objective here was to remove the dependency between your age and your likelihood of purchasing, and see if you can actually tease out of the math of that dependency. That conditionality went away. So if you recall from our work through this code that generates our data set, we used to get a line here in purchase probability that generated that based on your age. It basically took your age decade and divided by 100 to create that condition between your age and how likely you are to purchase something. So what I have done here instead is just hard coded that to 40%, so there is no longer any relationship between your age and your likelihood of purchasing something. So let's go ahead and regenerate that data set, removing that dependency between age and purchase probability. Now we can compute P of E and F given. Again, that's the probability of making a purchase of given your age. For some age group, we will pick 30-year olds again, just to be consistent. So again, we will compute the total number of purchases by 30-year-olds by the total number of 30-year olds, and we end up with a number about 40%, and we can independently compute P of E, which is just the probability of purchasing something overall regardless of your age. That comes out to 40%, so 39.840.0, pretty darn close. Okay, so in this case P of E is roughly equivalent to P of E given F, little bit different just because of random variation, but it's close enough that we can say that E and F are likely dependent variables in this case. So the math told us that P of E given F is the same as P of E more or less. And sure enough, that does reflect the fact that we remove that tie between age and purchases probability. And sure enough, so I hope you able to reach the same result and learn a little bit of something along the way about conditional probability and how to tease those dependency between your various features of your data.